Today we'll be basically reviewing what a fair game to go into the final. These are the topics that we cover so far. But before I go through the topic, let me go over the format. It would be the same as the midterm. Like 24 hours exam. The exam will be released before 2 p.m. on next Wednesday, July 22nd, and then it's due at 4 p.m. So you have about, I would say, 26 plus hour. There's a chance I'll just put it around between noon to 2 p.m. But depending on basically my schedule a little bit, but definitely before 2 p.m. The exam will be available on Canvas. Similar to the midterm, you have until 4 p.m. of the next day to finish. There'll be a live session between 2 and 4 p.m. on July 22nd. That's when you can ask questions. And I guess be based on the feedback from the midterm, I will actually add another Discord session from 7 to 8 on the same day. Basically, if you are working on the exam during the class slot, and you're like, oh, I don't have questions yet, and then you do more things, and you're like, oh, I run into more questions. There'll be another Discord session between 7 to 8. I will be taking all the questions you have. Any further question is done through email like usual. I will try to respond as soon as possible, but the response time has to depend on my work schedule. Uh, if it's in the morning, I'll try my best to cover and get the answer back to you. Is it going to be harder than the midterm? I think it's likely easier. It'll be less programming for sure, because now we cover parts that you need to kind of know things. So it'll be more on a question and answer kind of thing. I will make sure that the exam in the format that you can just randomly Google and find the answer. So it will be more theory questions if you want to put it. I'm going to show you some sample questions in a bit, right? And then additionally, there'll be office hour today, Friday, and Monday. If you need more, let me know. Basically, if you need more office hour, just let me know through email. But I would make sure that I'll be on Discord at 7 today, Friday, and Monday. Uh, Hopefully, if you still have any lingering questions, feel free to ask during the time. It's pretty convenient to show the screen that you're working on. I can kind of guide you through it. Uh, is there a demand for office hour after the exam for the last assignment, because it's due on Saturday afterward? So would it be helpful to have like office hour, say Friday, right before the assignment is due? All right, that's one yes. So I'll just assume that's a yes then, just in case. So, one token per assignment. Basically, you have until like kind of Sunday night, for that, but that's basically as much as I can push, in terms of like my own sanity to get everything graded. I can use one late token. Basically that literally the last day. I mean, I told earlier Friday is the last day I can do it, but then I push it to Saturday. Uh, Now Sunday. Basically, if you have late tokens, there's no, the assignment 1 and 2 is still being graded. I'm sorry, something came up, so I haven't had a chance to like fully grade everything yet. I am trying to rush everything as much as possible. I'm sorry, but I ended up having to like grade everything by hand, and that take way more time than using automated grader. Oh, do you want to use automated grader? Otherwise, you like if I use that, I think your grade drops a lot. So I think I'm kind of like want to make sure it's as flexible as possible. So here's a topic for the final. The first topic is data representation, program representation, assembly, right? These are the first part of the, I guess, post midterm material. And remember that programs and data are all in DRAM. So I'm going to show you the previous exam a little bit. So this is from last semester that I teach this class. It's called file processing, but it's the same class, system skill. So you will notice that there are going to be questions like, okay, what's the equivalent of certain thing, right? These are going to these questions are basically, I call it potpourri. It's like random questions that test your knowledge. Like what's the difference between EAX and RAX? What's the difference between little endian and big endian, right? Uh, what is a stack pointer? Why are they important? What's the purpose of the program counter or instruction pointer? So these are theory questions. I'm sure these are the type of question you kind of go back, look at the lecture, and you know how to answer that. Because it's 24-hour exam, I might put some like flipping, like I might make the question a little bit more interesting. This is the in-class exam, so this thing that you see right now, your upperclassmen they only have 2 hours on this, but you have 24 plus hours, so it will be a little bit different. There's a question on the jump table. This is almost the same as what you see on the in-class exercise. You can see here's the assembly, right? And then what I do here is ask you to fill in the space below, right? Over here. And if you did the in-class exercise, you would know how to work through this problem. One more problem about assembly is handling function calls, right? So over here, I'll put in like, these are my assumption. I will say, okay, input is the return value is in EAX. The input X and Y is say in ECX and EBX. I'll just basically make all the assumption for you. Follow the assumption. How can you actually maintain the assembly code, right? Basically, write the code that represent the function up here, which is just a plus b, right? But you have to handle the function call. So what else do you have to do? More than that, I actually have this table here where you would use it to represent the stack and what value goes into the stack. So this is the fair game to ask you during the exam. Another question is about chord size, right? Over here, what I do here is I have the starting address for my first instruction. Given the size of the instruction, what's the new address of each of this entry? So what goes in here? What should be at the address of this? Can someone tell me what's the address? So how many bytes is this instruction? Yeah, 5FB. You're correct. So the answer is 5FB. Why is 5FB? Because this is basically 1 byte. Right, so you just need to increment once. What's the 5FA plus 1? That's 5FB. What's the, so because it's 3 bytes, how can I tell this is 3 bytes? First byte, second byte, third byte, right? So what is the address for these instruction? What is 5FB plus 3? Yeah, 5FB. Make sure you can kind of like do hexadecimal arithmetic, basically do the addition. Last semester I felt kind of sad when I see the, like, you added wrong. So I'm not gonna take the points off that much, but you're not gonna get full credit if you do adding number and it turns out wrong. You might get like 0.5 point, like half a point or 1 point off from the from the full grade. So it makes me feel sad if you don't. Oh, so how? Okay, so the question is how about 5fe plus 3? How do you do that arithmetic, right? So you know that plus 3, 5fe plus 3, the e plus 3 becomes 2, right? 5fe plus 3, this is 2, right? ef1, f01. Oh, no, that's 1. My bad. I did the math wrong. E plus 3, right? So you go E, then F, then 0, then 1. Then you carry 1, right? You have the carry. So this is F, you carry 1, that becomes 0. You carry 1, that becomes 6. So it's 601. So this is 601. What's the next one? 604, right? Etc. etc. Basically, make sure you are being careful with arithmetic. This is a good helper because if you keep adding things in, this should add up to 6OE. I left it there to make sure that you can do sanity check. That hey, at the end of the day, that should add up to 6OE. This is a question that so many people got it wrong, but I think the problem with this particular question is because it's at the end of the exam. This is the last question on the exam, and people are rushing to get something on the answer box. So it's a fair game for me to say, okay, I make this assumption, right? That character is these many bytes, integer is these many bytes, a long integer is these many bytes, and then I assume that I declare this value, right? So what's the value in hexadecimal of this versus this versus this? Like a -20, but in an unsigned short int format. That I cast. Basically, these are the same value, but I cast it differently. One is short int, one is unsigned short int. So how does unsigned short int behave if it's -20? Oh, you mean the answer for unsigned short int 20? So 20 is a decimal number, is 16 plus 4, right? 16 plus 4, so that's 1, so that's this is 4, right? 8, 16, and then all 0. What is the short? Short is 2 bytes. So basically the first byte is 00 for sure. The second byte is right here, which is 1, what is it? 1, 4. Zero x 0014, right? So what's the hexadecimal representation of short int without the unsigned? Oh, can I repeat? Basically, this is 14, right? No, my bad. This is 20 in the decimal number. 20 equals 10100 in binary, right? That's the number in binary. What is 10100 in hexadecimal? That is 14, right? 0x14. That's equivalent to the value 20. And because unsigned short int is 2 bytes, so you need to fill in the rest of the 16 bits. 2 bytes is 16 bits, right? So the hexadecimal value of this is basically, this is because the rest are all zeros, right? So you just add in 00 to make it 2 bytes. This is the first byte, this is the second byte. All right, so what about short int 20? The only difference is now I don't have this unsigned, right? Does it matter? Yeah, So it's 0x14. You can pad it to 2 bytes. So this is basically the same as 0x0014. Right. So because it's a short int, that's 2 bytes. But essentially the same number. How about unsigned short int -20? What this? To do this, let me go through this example. To do this, you start with what is -20, right? What is -20? -20 is, you can start with 20, right? Then you do negation of 20 plus 1. That's the same thing because you want the two complement format, right? -20 is negation of 20 plus 1. Any question about this part? Okay, so what is 20? 20 is 0014, right? This is 20. So negation of 20 is basically F, right? So you flip all the bits, F, F. What is negation of 1? E, yeah. Oh, E. And then what's the negation of 4? B. Why is that? It's 1011, right? So negation of 20 plus 1 equals what? Oh, because I asked you to do it in hex. It's in the question. Yeah. So it's FFEC. So the question was like, why are we doing this in hex, not in binary? Because basically the question asked you to do this in binary. You can do this in oh no. The question asked the hexadecimal representation. You can do this in binary and then you can convert it afterward. That's also okay. It's the same thing. Basically, it's the same value. So this is -20, right? FFEC. Do I need to do anything here? If I say it's unsigned, it's already 4 bytes, so you don't have to do anything. So the correct answer is 0xFFEC. What is the value of this? What is the value of this? The value of this is basically you convert this to decimal will be equal to the value of unsigned short int of -20. Let's say you write this code in C, in the C language, and you put this unsigned short int to cast -20. What would happen is it won't say that, okay, that number is -20. It will say that number is whatever value FFEC represents, right? So what is FFEC in decimal? I'm typing it on Google so that, okay. I think this equal to 65516. If I do it correctly, I think it's that number. Right, so it won't treat this value as -20, it would treat this value as 65,516. How about short int of this in hexadecimal? Is it FFEC again? Short int is 2 bytes. Right, so it's FFEC again. First byte, second byte, right? How about this? I start with int I equal -20, and then I say j equal I, right? J equal I, but j is a character. This is only 1 byte. What's the value in hex of I? So that's the first question. What's the value of this I? How many bytes is the integer? 4 bytes, right? 4 bytes. Integer is 4 bytes. That's from my assumption in the beginning. So over here, I know that a 2-byte value of -20, so this is a short int. This is FFEC. How can I extend it to 4 bytes? Int, right? This is what you get. Basically, you add F, like all the ones. FFFFFEC. Add all the ones to make it 4 bytes. Because basically this is the same as -20 is basically negation of 20 plus 1, right? But now our number 20 is 4 bytes instead of 2 bytes. What is the negation of 20, but it's now 4 bytes, right? So this is 4 bytes. So this is 0x 000000014. That's the 4 byte value of 20. You need to negate that. So you get 0x F F F F F F E C E B. And then you add 1 to that. So you get 0x F F F F F F E C. So this is -20 in integer. Because, okay, let me put it this way. To represent a negative number, what you can do is you start with a positive number, right? So you start with a positive number, negate all the bit and add 1. So let's say I want to do what's the -1 in hexadecimal, right? So let me find some room here. Let me put it here. So what is -1 in hex? Oh, okay. Sorry. Let me rephrase the question. If 20 is two numbers, so if 20 is two number, like you said, basically 20 is 0x14. That's correct, right? And then you're questioning like why is -20 not 0x EC? Is that the question? Okay, because in C, in this like programming language, different data type has different amount of bytes associated with it, right? So a short int, let me scroll up. Basically, I put it here saying character is 1 byte, a short int is 2 bytes, an int is 4 bytes, and long is 8 bytes, right? Which means that let's say you look at a short int 20, you need 2 bytes, right? You need 2 bytes. So let me scroll back down, right? Short int 20. If you want to represent it, essentially that is 0x0014. So you with me, right? Basically, you need 2 bytes. 00 is 1 byte, 14 is another byte. Are you following this? Okay, so what do you do to get the negative 20? Flip all the bits and then add 1, right? So you flip all the bits, this is what you get, 0xFF EB, then you add 1. So that becomes 0xFFEC, right? It's the same process, but now you just need to make sure it's the same amount of bytes that you want to represent. So over here in this question, you know that short int is FFEC. Yes. Unsigned and signed, same hex value, same bits. It's just how we interpret the bits. 4 bytes is 32 bits. Yes, 4 bytes is essentially 32 bits. We said that, okay, integer is 4 bytes. So we need more things. Basically now, integer of 20 is essentially 0, 0. Ah, I can't draw. 0x00000014. That's the integer representation of 20. Then now I need to flip all the bits and add 1. This is what you get. All right, so that's the value of I. How about this? What's the value of j? Now I have I, right? So what is I? This is 0x f f f f f f e c. What is j? Which byte am I taking? If I said J is a character, which only is 1 byte, which bits here? Is it FF? Is it the second FF? Is it the third FF? Or is it EC? Which one of these box am I taking? EC, yeah. So J is 0x EC. It will start always with the least significant bits. Yes, so you get the least significant bits. Start from there. Then you do the casting. Character is 1 byte, so I'm going to just take that to 2 letters, E and C. The rest are kind of like repeat of the same. This one is shift left, right? So shift left, just make sure you do the shift correctly. Shift left by 10, make sure you add 10 zeros, and then crop it correctly. Make sure the end product is still over here. I is a short int, so the end product, make sure is still 2 bytes. Yeah, sure. So what is I? What is the I value of I over here? It's 0xFFEC, right? It's from our original question, right? So what if we do I equal I shifts up by 10? What if this is F, right? So this is the FF part, and then E is 1110. C is 1100, I think. Is that C? I think that's C. D, E, F. Yeah, that's C. So this is F, F, E, C. Are you all with me? Okay. When I see this and I wanted to shift the way I would do it to make sure I am careful with the bits. If I shift to the left, it's like I move everything to the left, right? And then I keep adding zeros. So basically what I would do here, I'll draw 10 zeros over here. Right? It's kind of like I take this chunk and I move everything to the left. It's the same thing, right? This is my end product after the shift left by 10. Then I is a short int, right? So how many bytes should I have? I is a short int, so I should only have 2 bytes, right? It only should contain 2 bytes. So I would start from here. This is the first byte, right? This 8880 here is the first byte, the zeroth byte, right? 1, 2, 3, 4, 5, 6, 7, 8. This is the first byte. So what you got from here is equal to, then the rest you throw it away. The rest is like all gone because your data type is only 2 bytes long. So what is this? It's 1011 and 000, like a bunch of zeros, right? So this is, what is 1011? 8 plus 3, 9, 10, A, B. So this is B, 0. Oh, I'm wrong. Actually, my bad. Let me erase everything here. That is too many bytes. Sorry. Once you do the shifting, first byte, second byte. So it's basically 0x00. Oh, wait. Okay, my bad. It's too late in the afternoon. I'm kind of weird. 1 byte is 8 bits. Okay, let me refocus. I think it's me being confused now. Let me refocus. 1 byte is 8 bits. So how many bits do you need in this case? 16 bits, right? You need 16 bits. You start from the rightmost, go left 16 bits, 4 bits, 8 bits, 12 bits, 16 bits. First byte is right here, right? This is the first byte, 00. Second byte is 0000 and 1011. This is B000. This is the value of hexabyte. You shift everything by 10. What if I shift right by 10? Right? So I start with F, F, E, C. So that's 1111, 1111, right? And then E is 1011, C is, oh, my bad. Dealing with too many bits. 1111, the first F, 1111, the second F, E is 1110, C is 1100. Right? You shift everything toward the right. The way I would do shift right is this. I'm gonna kill off the bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? If we are shifting short int, right? Short int should keep the sign bit, right? Because it's not an unsigned type, we should keep the sign bit. What we'll get here is our bits start with 1, 1, 1, 1, 1, 1, right? That's the rest of my bits. But because it's a signed integer, you just keep adding ones, right? So basically what you get is 0x f f f f. Right? I think that's all for the question for this part of the exam. How about unsigned? If it's unsigned, you pass 0 because negative value has no meaning. The jump table solution, you mean over here? This one? It's actually the same as the in-class exercise you have. I think, if I recall correctly, this is the same as your in-class exercise. So let me go through this for you, right? You start with, okay, let me tell you, the first thing you need to notice is where is my table? Where's my table? I'll see that table should be right here, right? I start with L9 and it's like a bunch of jump. So that's where my table is. Which one is case 0? So let me label the lines. This is line 1, line 2, line 3, line 4, line 5, line 6, line 7, line 8. Which line here is case 0? It's line 1, right? Line 1 which jump to L8, that's case 0. What's the default value? Default is when my value is more than yeah, text, that's fine. That's correct. But basically, default is whenever my switch case is going more than 7, right? If it's more than 7, it's always going to L4, right? Oh no, my bad. If it's more than 7, this is where you jump to L8. Why? This is the variable inside my switch case. Why can I tell that? You are comparing this variable with some value. Based on that, if it's above, right, JA is jump above, if it's above 7, if this value is above 7, jump to L8. Where's L8? L8 is right there at the end. Right there at the end. So you can tell that the at the end, what does the default do? This is the default case. Right? So what does the default do? It return result, right? So result is definitely EAX, right? So what do we do? EAX is -1, right? Result equals -1. So we can put in the first thing, right? Result equals -1. What is EDX here? EDX, whatever variable here, it should go into this thing, right? It's a variable, so is it A or is that B? Yep, that's A. How can you tell? If you look at the stack, right, EDX is 8, you go by 8, so it's lower on the stack, so it's the earlier variable. Basically, by 8, that's the first argument, then the second argument. Over here, you can tell that EDX is the first argument in my function calls, and that happens to be variable A. Any case that doesn't go to L8, so this is case 0, right? And it's go to L8, so that's the same as default. So you can get rid of this case, this case, this case, the 3 case go to default. What are the rest? You need to take care of case when A equals 1, right? 3, right? So this is when A is 1. This is when A is 3, when A is 5, when A is 6, and when A is 7, right? 5, 6, and 7. Any question here so far? All right, so this jump table, it begins with when A equals 0, right? Because that's how these logic work. It starts with L9. So this is base, right? Plus star EDX, and this happen to be, so star EDX happen to be A, right? Multiplied by 4. What is space? This is L9. Right, so basically it's L9 plus A multiplied by 4. What if A equals 0? If A equals 0, so you jump to L9, right? You just put in that equation. Basically, these instruction, you jump to L9 plus EDX multiplied by 4. Basically, you need to read this instruction, right? This is jump to L9 plus EDX multiplied by 4. And EDX is A. That's what the instruction means. Jump to the program at address starting at L9 plus EDX multiplied by 4. Are you with me so far? All right. So what is the address when EDX is 0? What do you mean by what's at the end? Can you clarify the question? What do you mean by what's at the end? Mm, that's it. Basically, jump to L9 plus EDX multiplied by 4. And because the earlier line that we compare 7 to EDX, in this case, oh, why multiply by 4? Multiply by 4 because we have this, right? EDX 4. These small thing, let me change the color. Otherwise, it's going to be too confusing. This part right here means that I will add L9 with whatever numbers go into the middle, EDX, that becomes the value of A, right? Whatever numbers that go into the middle, multiply by the number going to the last one, the third one, which is 4. You go, if you are not sure about this, go to assembly lecture part 1. Assembly lecture part 1, we have a slide that talk about how to read that particular format. And there's an equation there, which is you start with the number outside of parentheses. You start with the number outside of parentheses plus whatever value is in the first input here, but this is empty, so that becomes 0, plus whatever the value that are in the middle multiplied by 4. Yes, RB is missing, which is, you can, if it's missing, you treat that as 0. All right. Okay. So when A is 0, this is where you jump to line 1. Right? Line 1 is default. When A is 1, you go to line 2, right? Because that's the next 4 bytes. That's line 2. That's when A is 1. So you would then notice that anything that doesn't jump to L8 is non-default cases. The non-default cases are the one that you still need to fill in, right? So let's do this one by one. When A is 1, you jump here, right? When the A is 1, you jump here. What is that? You move 7 to EAX, right? So you move 7 to EAX, you jump to L2. What is L2? The end of my function. L2 is right here, right? So you do move 7 into EAX and then done. So if I go here, right? If I go here, which one I can pick? I can do result equal. Case 1, right? Result equal 7, break. How about L5, which is when A is 3? L5, what do I do? L5, I recommend EAX, right? So basically result is result minus 1, right? But what is EAX at this point? This is like a part of the trick of this question. You know that, hey, EAX is here. What is this value? You know that this is A, right? So this is B. So it means that result is B minus minus, right? When A is 3, right? Over here, this is B minus minus, right? And then break, right? So which one do I pick here to do that? I have a few more things here. I guess I can put it here, right? Result is B minus minus. How about the case when A is 5? It jumped to L4. What is L4? It's the same as A1, right? This is essentially same thing, right? So you know that when A is 5, it do the same thing as the earlier case. Anything I can do here to kind of cover case 1 and 5 at the same time? Right? If you go back, right? Case 1 and case 5, they're both going to L4. What is L4? Move 7 to EAX and break. I mean, let's keep going. I think once we keep going, it will be a little bit more clear. Now we established that, hey, case 1 and 5, it should do the same thing, which is basically result equals 7 and break. So one thing you can do is maybe put 5 here, right? And then put 7 here. That's one possibility. But then let's go back to our code and see if that would make it correct or not, because we need to cover case 6 and 7. Let's do case 7. Case 7 is simple. If it's 7, you jump to L2, right? L2 do nothing. Uh, I'm not sure you can do case 1 or 5 like that. But let's keep going. Let's keep going. I think it'll be more clear. L2 is not doing nothing. So over here, down here, you see that, okay, case 7, you do nothing. You don't have to do anything here. That's it, right? What are the remaining case? All right, stop sending me DUs. I'm not traveling. Wait, it's a confirmation. Okay, I probably need to check that, what's going on. When A is 6, it jumped to L6, right? What does L6 do? Increment EAX was increment EAX B plus plus. And this is break, right? So if I have case 6, I just increment B and break. Can I do it here? Case 6, B plus plus. The next line is break, right? So even though I have to break, even though I do not have the break right inside case 6, case 7, when you fall through this break. Is this correct? Yep. So is this okay to cover both case 1 and 5? Yes, right? So you can cover case 1 and 5. So let me kind of erase this and draw it properly. This is a correct answer. You can also change this to 1 and change this to 5. It's the same thing. Because both of them would get you the same behavior, right? You're gonna assign 7 to results and you return. Any questions about this? Basically, that's the answer. You can do case 5, 7, case 1, 7, or case 1, 7, case 5, 7. Both of them would be the same thing. Is the exam going to be like this? Somewhat. Basically, it will be like definitely not this exact same question, but something like this. It's a fair game. I can ask you to do this. All right. Oh, LEAL. Do we have it here? Nope. So LEAL. So LEL is essentially the same as let's compute LEL is basically compute this value, and whatever the result is, I'm gonna put it in the register. That's what LEAL is doing. I want to get the target address, but instead of jumping or doing anything, I put that in my register. All right, so let's take a quick 2 minutes break. I'll be right back. All right, so we can move on to the next part of the possible question you get. All right, I'll be right back. All right, so hopefully this is more clear with all the explanation. Let's switch to the next part here. All right, so we're done with the assembly related stuff. The next set of topic are what we covered in the last part, memory hierarchy, cache, and virtual memory. And I think I took the problem from the exam, plug it as your in-class exercise, and definitely go and work out in class 9, 10, and 11. Something like that are fair game. Look at the assignment 4. Something like that is also fair game. 3 questions. What is a TLB? I'm not gonna tell you how much that question is worth. It's not a lot, but that question will be there on your exam because I told you so. So let's switch. Let's switch. Sorry. Let's switch to the sample questions here. No, I don't. I'm not interacting with you, WebEx. So here again, right? There'll be like theory broad question, like what is the benefit of caching? This this next question, right? This next question, I will say, okay, L1 cache takes these many. Okay, let me draw. L1 cache takes say 1 cycle, L2 cache 5 cycles, and then main memory takes 100 cycles. You have 90% hit rate from both L1 and L2. If you have to process 1,000 memory requests, which is load and store, that has to go to DRAM, how many cycles does it require? Over here, for example, this is actually pretty easy. So let me go through this question for you. You have 90% hit rate, right? For L1 and L2. So how many go to L1? Actually, it's 1,000. Everything needs to go to L1. It's whether it's a hit or a miss, you need to go access L1, right? Don't fall into that trap. Basically, this is 1,000. How many then would go to L2? How many need to go access L2? No, not 100. How many? How many would? Oh yeah, yes, that's 100. My bad. 100. You are correct. 100. Why is it 100? You go to L, 1,000 of them go to L1. 90% of them will stay in L1 because your data is there. The rest, 100 of them would miss in L1, go to L2. So how many of them have to go to the memory? 10, right? So how much time does it take? L1 access, 1,000 of them, you multiply by 1, right? Because it takes 1 cycle, plus 100 multiplied by what? By 5, and then plus 10 multiplied by how many? 100. 100. And this basically make out leave 2,500 at the end. Having this formula is kind of okay. Would it be one? Why is it 110 for L2? Because 100 of them miss in L1, right? All the requests miss in L1 need to access L2. They need to access L2. So 100 of them need to go to L2, but then because there's 90% hit rate, out of that 100, 10 of them would need to then go to DRAM. So it's 100 for L2. Good question. Is it possible for program to have 100% cache hit rate? Yes, no? All right, one vote no. Anyone vote yes? All right, one yes, one no. The answer is yes. Why? Go to explanation of thrashing. Cache miss rate. 100% miss rate means that it's you have so many thrashing that you never you can have cache thrashing. You can have every time you see a done address, it's a new address. So there's no way you can know what's that address, right? Oh yeah, so if you be careful when you read the question. I know it's also tiring. Basically, going through this question is tiring. Try to stay awake and conscious because it feels bad when I grade it and it's like I'm not sure if you read the question wrong or not, but it's like it turns out like that's the wrong answer. Uh the purpose of the tag store to basically make sure that the virtual address, yeah, store the address, make sure that's your data, right? Caching basic, this is the same as in class exercise, so I'm gonna skip that. Is that okay? This is our in class 10. This is our in class 11. Can you do see which one? Do you mean this one? Or do you mean which one? Which one? C? You mean this? 2C? Okay, sure. All right. So the question asks about the set ID, but let's go back to our cache structure, right? 32-bit byte addressable process, single level cache, right? Four-way, each cache block, right? The whole cache is 16 kilobytes. You have four-way, each cache block is 64 bytes. If you know that it's byte addressable, each cache block is 64 bytes. What's the amount of list? So if you look at the address, it's something like this, right? Byte and block. This is the set ID. And then this is the tag, right? How many bits is there? How many bits is how many bits here? Block of 64, basically that's 6 bits. Right, block of 64. All right. So you know that the set ID start from the 6 bits onward. If you know that it's 16 kilobyte of data and I have four-way, how many cache set do I have? How do I calculate that? I start with 16, right? Kilobyte is 1024. I divide it by 64 bytes, so that's the size of my cache block, multiplied by 4. What is this? This is 4. This becomes 16. What is 1024 divided by 16? It's a 64. Yep, 64. So there are 64 sets, right? How many bits do I need for the 64 sets? Log of 64. That is also 6 bits, right? So now you know that if my address is, let's say, dead beef, right? What is dead beef? D is 1101, right? That's D. E is 1110, that's E. A is 1010, that's A. D again is 1101. B is 1011. E is 1110. Oops, my bad. So which one is a set bits? You start with knowing that, okay, this is the byte, right? And block. So you know that the next 6 bit, which is this, is the set bit. What is that? 111011, right? What is that number? Yeah, 3B. What's that number in decimal number? This is essentially is 111111. minus 100, right? This is 63. This is 4. So basically it's 63 minus 4. That's 59. No, not really. I just wonder you. You can answer 3B. I'm fine with that. Just clearly mark it. I'm just telling you how to quickly convert it back to the decimal number. So yeah, to answer your question, do you need to convert everything to decimal at last? Not really. I mean, I will not force you to do that. I can read the bits, but it's good to be like knowing how to do that. To be safe, just leave it as hexadecimal so that I don't see like a wrong version, right? But I'll just like make sure that it's So what's the set ID for beef? Yeah, I'm sure I'm hungry when I have these questions, all like meat related things. It's actually the same number, 3B. Why? Because the set ID is coming from the last EEF, right? So the EEF is essentially the same bit pattern. So you can just say 3B. That's the same answer. So the next question is about the tag bits. You follow the same process, but now the tag bits come from this part. So this one is F, 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 F. This one is going to be A, B, C, D, 1. Any questions? If you have questions, follow the exercise. Virtual memory, we covered that. Like this is the third time. If you're not sure how to do this, go to the video from last Friday. All right. I'm not gonna do this for like a third time. Then there was a question on the translation leukocyte buffer. So what's the benefit of translation leukocyte buffer? VIPT, PIPT, we covered that in class already. And that's it. Then we have the extra credit, which this is way too hard. So at the end of the day, no one attempted. I actually have a warning: do not attempt unless you're done and you have nothing to do, nothing else to do for the exam. I will not, I will not tell you an answer for this. I might have the variant of that. What do you mean by can you do the previous one? Which one? This one, the TLB, and VIPT, or this one? The TLB one. Okay. I'll skip part A. Part A is from the lecture. So part D. Let's see, was TLB part D. Oh, okay. So VIPT, the benefit of VIPT. So what you need to do here is, I'll just say guideline, right? Follow this route. PIPT. You do this. How much time to get physical address, right? Plus time to access the L1. VIPT, this is the max of time to get the physical address and time to access L1. That will work for BCD. What is B and C? Part B is how much time do I need if I have a TLB miss and I1 cache hit, right? Two-level page table, TLB access take 1 cycle and one cache access has 1 cycle. This is a timeline. Check TLB, right? That's 1 cycle. And this is a miss. So you then do page walk, right? That's 200 cycles because that's two-level page table, right? So you now get the PA, look up L1 cache, right? Which is a hit, so that's 1 cycle. So that's 200 plus 1 plus 1, which is 202. Any questions? How can I tell it's 200 cycles? Because I said that's two level of page table. I need to go to DRAM twice to get my physical address. Don't forget the part that you need to look it up in the TLB, and don't forget the part that once you have a physical address, then you look it up in L1. And the 200 is spacewalk. All right, so that's it for the previous exam. So it is kind of like roughly this difficulty. Yeah, and you just say in cycles. I am not gonna force you to like, okay, with now the processor is this gigahertz. How much time in seconds is that? Basically, you convert cycles into seconds. You can do that using a calculator, but I'll just ask in cycles. And that's it for today, basically. Any other question? I have like a bunch of scratch pads here that I can answer any additional questions. Because before we leave today, or I guess last call for in class 11, but we did it already. So what's the expected completion time for exam? That's a great question. I'm aiming for about 3 hours, so a little bit longer than usual because you have definitely 24 hours on this. I assume that out of that 24 hours, 10 is going to sleep. I'm not sure how many hours you usually sleep, but you have 14 hours left. I assume that in the maximum case, you have 5 exams on that day, which I hope that's not the case, right? If any one of you ended up in the case you have 5 exams on the same day, definitely let me know. Then you divided 14 over 5 to get about 3 hours. So I hope you spend about 3 hours on exam. What time is the exam? Definitely will be posted before 2 p.m. on Wednesday. I would try to put it in a little bit earlier so you can kind of like go and take a look at it. Uh, and yes, I will try to make the exam not too hard. Uh, is it for the coding part? Is it going to be as time consuming as A4? It would probably be more like write the assembly code and I need to grade it by hand. Uh, I would guarantee you my question doesn't require much creativity. If you ended up with assembly code that about like 5 pages long, something is wrong. All right. So you can write the answer in Microsoft Word. You can write it directly on the PDF. You can write it on the paper. Make sure I can read your handwriting. And submit as a PDF. Either way works. You can submit a .text file, as long as there's a way for me to read what you answer, right? And yeah, about handwriting, I think most of the time I should be able to read most people, human being handwriting, but please be considerate. I know that I know that with time crunch, sometimes the handwriting get worse and worse, but you have 20, I would say 24 hours to write this. Yeah, make sure it's readable. Writing question be more than the coding, right? Yes, there'll be more writing question than coding. The coding question, it might be like something like assignment 3, where I ask you to like, okay, uh, write the function that use logic operations to do certain things, and you have these many operations. You cannot exceed these many operations. Something like assignment 3, part 1, like that can be the coding exercise that I want you to kind of play around with a little bit. Oh yeah, A3 solution. Yes. Let me pull it up. Okay, actually, I think because people might reuse it for the next semester. I mean, I might reuse it. Is it okay if I go over that in office hour so that it's not recorded and people so that the next year is like not coming in and listen to the video and know how to do it. All right, yeah. So I'll be in office hour to go over the exercise, the assignment 3, part 1 for you. Yeah, yeah. Anytime on during the office hour, I can show it to you. I just don't want this recorded. That's all. Yeah, yeah, you're welcome. So that's it for the class. Thank you so much for I guess keeping up with this. I know it's never perfect to have like all online format, and I think you did really well so far. I'm trying to be as lenient as possible, and thank you again so much for the mid semester feedback. I am trying to address it as much as I can on like a exercise in class. Trying to make sure you get to like do the coding, but it is a little bit too late because I wish I have this feedback earlier than the midterm so I can do the like a hand holding for the C part, because I think I feel like that's the part I regret actually. And then that's the feedback is really. Do we get partial credit for coding assembly? What do you mean? You mean the exam, or do you mean the for on the exam? Yeah, yeah. If you basically on the assembly part, yes, I would give partial credit. That's why I need to grade it by hand. So I'm trying to figure out like, okay, this is the part you do, and these are the mistakes. Uh, just be aware that even though you get like close to full credit or full credit, sometimes the code doesn't, it's not going to work, right? But if I know what you're trying to do, and I know because of the time limit, I'm not gonna overly penalize for things that you're trying on that are doing in the right direction, right? So yeah, I would give partial credit. It's not all or none, right? I don't think all or none kind of exam is fair. Um, yeah, I'm afraid so too. I'm kind of afraid that next trimester is going to be online again. Especially the weird COVID case that we got, yeah, 2 days ago. It was kind of like, I think it's kind of anger everyone that it's like, oh yeah, almost out of this, and someone screwed this up. So yeah, not much I can comment on like the online like again next semester, but I think one thing I can assure you is like we as a lecturer on this side, we also like learning and trying to like adapt as well. So one thing I can tell you is probably next semester will be a little bit less hectic in terms of the organization, right? One thing I regret again for this class, I think there's a benefit of having to make sure everyone here turn on their video. Oh, okay. The lab might be on campus. I see. So I guess I'll just need to talk to your department and see how the format is going to be. I mean, I would love to like be able to like talk to you in person as well. But yeah, I don't know if you have to come on campus or not. And the main issue about these questions is essentially because I'm part-time lecturer, I'm kind of stuck with like KMUTNB as a Thai scholarship contract for 20 years. Uh, Oh yeah, and also like international students are not going to be in Thailand, for sure. It's yeah, it's all hectic. Like even me, I'm trying to get my wife back in Thailand. It's been like hell for me. She finished her PhD and now she's stuck in the US. Yeah. Um, yeah, well, it should be soon in a month or two. Yeah, we will be back together finally. But any case, I kind of wish it's open. I wish to like see you in person. Otherwise, I mean, if I'm teaching next semester, my new policy would be like everyone here needs to turn on their video. I want to make sure at least you're not sleeping. And and at least if I ask question, having the student nodding their head, it's like it's a feedback that I can see that okay, should I slow down? Should I speed up? Right? I think the chat features have been helping quite a lot in a sense that you can always send a private chat if you don't want to tell who you are to your friends, right? It actually encourages you to ask all the questions. Uh, I might even apply this to like even though it's in-person class now, I might try to find a way to like, still have this private chat option on my screen so I can actually like address the anonymous questions. I feel like I somehow I got more questions compared to in-person classes. Uh, so there are pros and cons for sure, and definitely cons outweigh the pro. And I kind of wish it's in person. But yeah, everyone here should be safe as well. Like I would be really sad if like someone here like caught COVID because we make it in person, right? Yeah, so it's been really enjoyable. Thank you so much for like bearing with me. One more lecture, well, not lecture, but I'll be here to answer your question related to the exam. And then one, two, three, five more office hours. Office hours today, Friday, Monday, Wednesday, and Friday. That's as many as I can. I think more than this, I might go crazy. But then I'll proctor, I'll check Discord and I'll answer your question. Uh, the video today will be posted on YouTube probably tonight or tomorrow. If it's not posted, can one of you please ping me? That would be great. I would definitely appreciate that. And that's it for the class. Thank you so much for the great semester. Yes. Any question? Oh yeah, remind about the what rebel conversion? Oh yes, yes, yeah, 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 yeah. I would put it in. Yes, thank you so much. Yes, I would put in the table to convert log of numbers. Yeah. Thank you for reminding me that. I definitely forgot about it already. Yep. Sure. Let me make sure I put it on the blank exam sheet for now, so I have it at the end for sure. All right. Yeah, thanks for that reminder. So let me switch back to my desktop. Okay, that's it for the class. If you have to go join the other lecture, just feel free to. If you have questions, feel free to turn on the mic. Feel free to type it in. Good luck with all the rest of the assignment for all the classes, as well as the rest of the exam. If you have like 4, 3, 4, 5 exams on Wednesday, let me know. There are ways around it. I don't want your life to be miserable because of the exam conflicts. Sometimes I'm a madman, but I'm not that evil. All right. Yeah, thank you so much. Sure. So I guess the questions about the